At the very beginning of the talk, I'd like to briefly introduce the company. GlobeCore has got a solid experience in manufacture of industrial equipment for energy sector. The product range is quite wide, and it includes transformer oil treatment machinery, insulation drying machines, equipment to freeze impurities out of transformer windings, transformer evacuation machines, and oil filling equipment. We have supplied our equipment to over 40 countries worldwide, having Europe, Asia Pacific, Africa, Middle East, Persian Gulf countries, and Latin America among our customer areas. Especially, I'd like to stress transformer oil treatment machinery, as the subject of this meeting is oil regeneration technology to be presented at the sample of CMMR plant by GlobeCore. Now, let us start. But coming to the background of regeneration technology invention, I'd like to bring you to oil purification talk first. Next couple of slides represents very well-known basics about transformers and transformer oil, but they will help us to focus better on the subject of our today's talk. Transformer oil is a mineral insulating oil. Except of transformers, it is used in tap changers, reclosers, bushings, and switchgears. There are naphthenic and paraffin oils, and as naphthenic oils are running out, paraffin oils come in usage due to developed refining techniques. Moving to oil chemistry, it's worth to stress that oil is very complicated structure. Generally, most compounds in oil are still not fully known. But oil obviously contains hydrocarbon and non-hydrocarbon compounds, where hydrocarbons are made of hydrogen and carbon molecules, while non-hydrocarbons are the compounds where carbon atoms are replaced by 1, 2, or 3 sulfur, oxygen, or nitrogen atoms. Non-hydrocarbons in transformer oil are naphthenic acids, esters, alcohols, as well as sulfur and nitrogen-containing organic compounds. Oil is well known through its 4 core functions, which are the following: dielectric strength provision, because oil acts as a dielectric and insulating medium; heat transfer, because oil means to be cooling medium; solid insulation protection, which means oil to be a barrier between the paper and damaging effects of oxygen and moisture; and diagnostic function, because oil is a perfect diagnostic tool to evaluate true condition of a transformer inside, and especially to evaluate true condition of solid insulation. I think that when we come to speak about oil function, first of all you think about dielectric strength and heat transfer. But in regeneration, solid insulation protection is extremely important, as it is the reason of the technology to arise. When it is for purchase, oil draws the most attention to the following specifications: dielectric strength, color, flash point, interfacial tension, pour point, specific gravity, viscosity, neutralization number or acid number, in other words. But when it is going on about regeneration, we consider more factors if to compare with oil purification or degassing. These factors are water content, tan delta, also known as power factor or electrical dissipation factor, oxidation stability, and polyaromatic hydrocarbons. To assure good quality of transformer oil, we should pay the most attention to 10 delta, which is the crucial criteria for evaluation, especially when it's going on about high voltage transformers over 400 kVA. Up to date, we can meet inhibited as well as uninhibited oils. Mostly uninhibited oils can be found, for example, in UK or Japan, but there is a trend for generation and transmission transformers to become inhibited, as inhibitor results in oil life extension. Basically, antioxidant inhibitor DBPC 2.6 is employed. It is only 0.3% of oil. Nevertheless, some companies have recently shown a tendency to increase it up to 0.4%. Now, I'd like to bring you just right to purification or oil degassing talk to show the difference between purification and regeneration. Please remember that regeneration does not replace purification, as both of them are very important for transformer maintenance. Just to refresh in your mind, purification means removal of water, gases, and sludge from transformer oil. By the way, this is what GlobeCore oil purification plants can perfectly cope with. There are different techniques in oil purification business, but vacuum dehydration is an internationally accepted way. Obviously, the reason is we need to get water content of 3 ppm in some transformers, as well as gas content only about 0.1% of volume and sludge content about 0.2 microns. For large transformers manufactured by Siemens or Toshiba, these values have become standard. They claim that oil in their transformers should meet these specifications at the operational site. Anyway, it is objective for the future, which is still effective for currently manufactured and installed transformers. However, the reason for such tight specifications is transformers have become much smaller at the same amount of power. So the oil and the paper and the dielectrics have to work much harder to retain insulating properties in a transformer. Both stationary and mobile plants are effective and easy to operate. To develop this talk, I'd like to draw your attention at the next slide, which exposes typical GlobeCore high vacuum degassing plant. It is 10,000 liters per hour of capacity. You can notice that it is small size and lightweight design. Typical filters used in such plants are coil series and cartridge filters. Now we are coming to regeneration. And I would like to give you a very important definition, so I encourage you to perceive it accordingly, because it is different to purification. When due to the aging process, oil in a transformer reaches a stage, which can be a period of 10, 15, up to 20 operational years, where oil purification, degassing, is no longer effective. Oil must be either changed, what they mostly do today, or regenerated, what would be a perfect alternative. Regeneration is the complete treatment of oil to like new condition. Of course, it's impossible to reach new oil specifications for the 20 years old oil. But like new condition means correspondence with the standards disposed for a new oil. When we say that we bring 10 years old oil to like new condition, we mean that oil will meet its specifications from 10 years ago. The reason is, as transformers develop in larger kVA, so the oil has changed in last 15-20 years. Thus, such oil suppliers as Ninas or High Volt have improved their refinery performance to give a higher quality oil, especially for usage in high voltage transformers. Now, let's have some more definitions of oil conditions. New oil is obviously deemed to be unused. Re-refined oil is an old transformer oil passing through refinery process. As a result, we get basic uninhibited oil. This process is contemporary unpopular. Some companies talk about refurbished oil, what we call an output of degassing or purification. And now we are coming to regeneration again. The term is used in Europe and Africa, while reclamation term is used in Canada and USA. Process is enabled by fuller earth sorbent. Both stationary and mobile performances are equally effective, and besides, latest designs are environmentally friendly. Next few slides I am going to present aim to refresh common known facts about transformers in your mind. Anyway, I'd like to engage them to concentrate better on the sense of regeneration technology application. So, transformer insulation system. In fact, this is kraft paper to make up windings. The slide shows its mechanical strength and dielectric strength values, and just to add up, it's cost effective. Importance of kraft paper can be revealed in the following facts. Insulation is definitely the most important part of a transformer to maintain, as it is the weakest link in any transformer. Life of insulation is the life of a transformer itself. It's very simple, but crucially important. Insulation requires early and swift attention. So, we have a short of paper to provide mechanical, dielectric strength and dielectric spacing. Here you can see typical copper conductor wrapped in kraft paper. Pressboard cylinders support and separate the windings from the core. Pressboard spaces support and separate coils in the winding. And there are pressboard cylinders to support and to separate high voltage winding from the low voltage one. How does paper work? Let's have a transformer within normal load. There is a dielectric clearance between the windings. The paper wrapping and board spaces withstand the load when transformer is new. Here we've got normal load for the same transformer, but it has aged. Thus, it has lost the ability to maintain dielectric clearance. And we have come to a question. So, what if a transformer is held together by paper? It can be under any stress, as it has no moving parts, can it? Other than on-lower tap changers and regulating transformers, transformers don't have functional or mechanical moving parts. But transformer does move as it undergoes vibrations. Mechanical vibrations, switching surges, line surges, and limited short circuits. Do you remember previous slides exposing dielectric paper between the windings? If the insulation paper is not of correct standards, it damages dielectric clearance when there is a surge load. And depicted, you can see typical stress which transformer windings undergo. So, now we can agree that paper is the most important part of a transformer, can't we? We've got to know that paper and oil oxidize and age. if you take a piece of paper and pull it over, you make a test for mechanical strength or for degree of polymerization, dP. When the paper is new, dP is 1200. As long as the paper is getting old, this value becomes about 200. Standards of International Electric Engineers Institute say that transformer arrives at the end of life when dP loss is 75%. And beyond this point, transformer may not withstand next surge load or short circuit. And here we have come to the next core point. How does the paper insulation lose its strength? It happens because of oxidization, which takes place in a transformer. Besides, all the metal and paper are not sitting alone inside it, as the transformer is filled with mineral oil. Thus now we have arrived to application of regeneration technology. Any servicing company works with the oil. Let me briefly remind what oil does. It provides dielectrics, which is insulation. It protects paper insulation and provides cooling. Paper insulation is extremely important now. Notice, all the time we are talking about the paper, as it is the weakest point in a transformer. So, as we can protect the paper, we make a transformer operate longer and save money. And this is what we should do by means of regeneration, because it focuses on maximizing of a transformer operating life. And this is the main reason why customers buy these plants. Let's imagine a state utility which has 5,000 transformers, and you can make all of them last 5 years longer. What the value spared will be? Millions of dollars, because they don't need to install new transformers. Thus, regeneration means to look after utility assets. You may have an obvious question. Can it be cheaper just to change the oil rather than regenerate it? No, and I will prove you why. Until now, we have been speaking about oil strength. But what is its main weakness? First of all, oil is an organic compound. There is no chance to prevent formation of oil decay products in a transformer. The reason is transformer has breathers. And as a transformer heats and cools, they suck in oxygen inside from the atmosphere. Besides, oil undergoes oxidization decay as well as paper. So, how does oxidized oil destroy a transformer? First of all, when oxidized, oil can be very simply revealed by its color. Take a sample in a bottle and you will see it be very dark, red-brown. But what's inside? Following bad products come inside a transformer from oxidizing oil and then take up residence in the paper insulation. Acids: low-weight molecular acids, fatty acids, free water, moisture, dissolved and in emulsion, visible asphaltene sludges as well as dissolved asphaltenes, peroxide gas, alcohols, metallic soaps, aldehydes, ketones, lacquers, color pigments. And now we are back to the paper again. Transformer paper acts like the paper in car's oil filter. It filters above decay products out of transformer oil and holds them, destroying insulation. Now I'd like to speak about moisture affecting a transformer. Moisture comes to cellulose basically from 3 sources. Moisture left in by manufacturer. Moisture incurred by thermal degradation during service life. In other words, as the paper oxidizes, it produces moisture. That's why there is the moisture increase while transformer is aging. Moisture absorbed through unmaintained breathers. If to take all these factors together and to add in heat as a control factor of insulating system, we discover oxygen in the cellulose. Then we get what we call chemical degradation, which is a breakdown of paper. It means that we gain acids, peroxide, more oxygen, and thus more moisture again. It results in degradation of mechanical strength. As well it does in dielectric degradation, that is dielectric properties loss. And this is the result. And now we have come close to another core point. How can regeneration plant help a transformer? First, when should we do regeneration? Every 10 years. Why? As we have discovered, oil oxidizes and decays. But if we can keep oil in good condition to protect paper insulation, we will expand transformer operating life. So it's a matter of logic to do regeneration early rather than wait for 25 years. Also, DP value is still very good in 10 years, and oil hasn't become yet aggressive to the paper. Take oil sample and look at its color. If you see it has changed from dark yellow to light orange or brown, you have aggressive oil. For extra high voltage transformers, tan delta increases and interfacial tension reduces. This is how you can normally determine oil condition. And the last fact we all know, oil acidity increase negatively affects paper which we try to protect. Exposed is the chart of neutralization or acid number versus interfacial tension. At the bottom we have acid number. Vertically, interfacial tension is indicated. The colors are different colors of the oil. If acidity is 0.2 and the oil is brown, it's a bad oil, and interfacial tension is very low, about 20-25. As you can see, color curve drops down because as the acidity gets worse, interfacial tension levels off. As we have just mentioned, 0.2 acidity oil is aggressive for paper insulation. That's why recommended time to do oil regeneration is when acidity is 0.08. 30 years ago, there was a recommendation for oil change when acidity came to 0.5. But those days, transformers were very big with lots of oil and paper, thus they could go ahead until that value. But today, if the customer has, let's say, 500 MVA transformer, it's going to be small for the same amount of power. So both the oil and the paper have to work much harder, because transformer manufacturers try to keep the cost down, saving oil, steel and paper within the same effectiveness of performance. One more negative factor which brings us to regeneration is water. Water is a driving force of acid formation in paper. 97% of water is in the transformer paper insulation. Oil purification is not a transformer drying out, as it removes water from the oil but not from the windings. It's impossible to take oil purification machine, bring it to a transformer and dry it in one day out, as the moisture is accumulated deeply in paper insulation. If oil purification plant is put in a transformer continuously, day and night, for 4 months, it will dry the windings, but everyone can imagine how economically ineffective it is. Regular purification is an important part of transformer maintenance in terms of regeneration, as it reduces oxygen, which is a driver of oil oxidization. As well, purification removes combustible gases such as ethane, ethylene, methane, carbon monoxide, and carbon dioxide. All of them are in the oil, and as a transformer is aging, they contribute in oil oxidization. All mineral oils can be regenerated successfully to be used over and over again. In other words, once regenerated in 10-15 years, Oils can be treated this way in next 15 years and in next 10 years again, and so on and so forth without operation outage. Plants can be stationary or mobile. Both types can operate on energized transformer. But if there is a safety issue in a company or in a country, as effective can they be on de-energized transformer? Regeneration is up to date the most effective way of oil treatment, aiming oil usage again in the same or alike electrical equipment. There are no restrictions for regeneration cycles to be executed. And now let's speak about one more oil regeneration advantage, which is an oil price. We all know it from the television. It is about 120 US dollars per barrel. In the days of economical crisis, it was about 150 US dollars per barrel. But now customers don't need to worry. Let's get back to our state utility with 5,000 transformers. They don't need to buy new oil, as they have enough of it inside the transformers just to regenerate. Thus, primary purpose of regeneration is to protect paper insulation and by these means to expand transformer lifespan. Its secondary purpose is oil save. Both of the purposes should be taken into consideration very seriously, as they bring us to cost effectiveness and money saving. Now, when you come back to your boss and he asks you why to buy a regeneration plant, you will give him a motivated answer. Other advantages of regeneration are the following. When energized, transformer is no money loss and no inconvenient customer. Regeneration is easy to do by one operator. No oil transportation is engaged. Now you can see that regeneration is safer and more cost-effective than oil change. Try to imagine oil change. It's a de-energized transformer to drive clients inconvenient as they're burdening income loss. It's 10 people of operational staff as well as trucks involved because you need to pour old oil in cans and rev it out while you are bringing new oil. To fill a transformer with new oil, vacuum should be pulled for 2 days, and only then it can be energized. It would be a risk for environment besides, should the oil spill down inside the ground. So, what's cheaper? To organize all mentioned above or to have at least one oil regeneration plant? The answer is going without saying. But most important is to remember that when you change oil, 15% of old oil stays in transformer windings. So consider, we put new oil, 10–15% of old oil is still in the windings, and in 1 month's time an equilibrium happens in a transformer. It means that contaminants come out of the windings and enter new oil, so oil degradation starts again very quickly. Simple comparison. If you take 1 liter bottle of milk and put a few of sour milk inside for the night, in the morning the whole bottle will become sour. The same happens to a transformer. Could you remember that today we have stressed we should bet to start regeneration at 0.08 acidity? That's why, if we do oil change, leaving 15% of old oil in the windings, very soon will we arrive to aggressive oil acidity. Surely we had to do oil changes sometimes, but we do have an alternative now. To regenerate oil after 10 operating years, it takes 1 day. To regenerate oil after 20 years, it takes 5 days. Until now, we have been speaking only about technology advantages, but there are disadvantages as well. Therefore, there is not sufficient mobile equipment available. Think of all the transformers in your area. They might be thousands. Taking into consideration that you should do oil regeneration every 10 years, you will not cover the whole network before you should do your very first transformer again. There are few manufacturers of plants, operators are not well trained about correct plant application. But the most obstacle is electric engineers and decision makers are slow to embrace this new technology because they feel embarrassed. It can be explained. Because electric engineers have a huge responsibility not to mistake and to keep the light. But the world is evolving and we should move ahead. Timely studied, regeneration expands transformer life for at least 5-10 years. This is approved by ABB statistics after 10 years of successful technology implementation. Logic says that we can go even further. Of course, regenerated oil is not the same as the new oil. Since its start, oil ages and loses its antioxidant properties. That's why we add an inhibitor DPPC 2.6. As DPPC comes down in 2 years, we should add it again after regeneration. But even different to new oil, regenerated oil will save big money. Besides, only 1–2% of oil is normally lost after regeneration. Statistics speaks on itself. There are 8 regeneration plants in South Africa and 10 regeneration plants in Canada. Once we have mentioned today that regeneration is enabled by Fuller Earth. Its properties are the following. It is naturally occurring absorbent clay, which easily absorbs impurities from the oil. It has crystalline structure, which absorbs large amounts of acidity and 25% of water. And what is also very important, its porosity is up to 125 square meters per gram. This is what drives absorption of contaminants from the oil. Once we have mentioned today that regeneration is enabled by Fuller Earth. Its properties are the following. It is naturally occurring absorbent clay, which easily absorbs impurities from the oil. It has crystalline structure, which absorbs large amounts of acidity and 25% of water. And what is also very important, its porosity is up to 125 square meters per gram. This is what drives absorption of contaminants from the oil. Now let's look at Fuller Earth usage in all design machines. Here we can see 3 parallel tanks, heater, pre-filter, fine filter, inhibitor injection and oil outlet. So the oil came through the pump into heater, then past chorus filter, Fuller Earth columns, fine filter and left the plant. Fuller Earth acts as a sponge. Once it's saturated with the contaminants, it stops working. In all design machines, it was put in the columns. When it was exhausted, bottom lid of the column was opened, sorbent was disposed and replaced with a new one. This is how typical plant looked like. This slide shows one in the USA, sample of 1996. The column is opening to drop saturated Fuller Earth onto the ground. But the problem was that Fuller Earth thrown away usually contained 6% of oil, which had its cost. So, operation became expensive and environmentally unfriendly, as rains drove oil from Fuller Earth, disposed into subterranean waters, and that brought to negative result. New machines suppose reactivation of Fuller Earth. In this design, Fuller Earth reactivation is fully automatic and enables a regeneration plant to process oil again and again using the same Fuller Earth. Once poured into the column, Fuller Earth doesn't need to be removed from the plant for 2–3 years. The concept has changed. Regeneration plant cleans Fuller Earth on its own. separates sludged oil and gives treated oil. So next day you can use the same fuller earth to process the oil. Now you see how cost saving comes in, as we don't lose oil in saturated fuller earth for disposal and keep consuming the same fuller earth for 300 types. This is typical GlobeCore plant. It's full regeneration plant with vacuum degasser, fuller earth section and computer control. If you want, you can just use a degasser for oil purification or to combine it with fuller earth. For example, you come to a substation where one transformer needs only oil purification while another one needs both purification and regeneration. To do all this work, you need the same machine and only one operator. There are some important regeneration results. It improves dielectric strength, it decreases tan delta or dissipation factor, it increases interfacial tension, resistivity, and oxidation stability if to add back DPPC antioxidant inhibitor. This is how you can typically install a regeneration plant at site. Here we can see transformer valves, a special automatic valve. Oil comes to the machine, undergoes a regeneration cycle and goes back to the conservator, eliminator and check valve. And if you operate this circuit in this direction, you can operate on energized transformer. We have a protection also. We install pressure device in a transformer. This device measures oil height up to the conservator. Automatic valve is connected to oil regeneration machine as well. So, if there is a problem at site, pipelines loosening or a problem in the machine, oil level will drop and pressure sensor will measure this decrease. If it's, let's say, 200 mm, the sensor will shut down the plant and automatic valve will close to protect a transformer. First energized operation was executed on 760 kVA transformer in Canada in 2001. Normally, the machine stays outside substation, hoses join it to a transformer, chassis should be earthed for transformer earthing value, and copper pins of a substation should be put into the ground. One more problem regeneration escapes is mixing oils. Usually, all older oils of different brands, such as Nines or Shell, can mix with each other, except Chinese oils. There was an experience some years ago when, after regeneration, a couple of different Chinese oil brands mixed. After 1 year, oils reacted with each other and got black. When Nines says that its oils can be mixed with others, most probably this company aims to protect oil market, but we can't completely eliminate the risk. New oils which can't mix with older ones shouldn't be used to avoid probable contaminations. Silicon oils can never be mixed with mineral ones. If at least 10 ppm of silicon oil enters mineral oils, it incurs big problems for oil purification machines because high foaming will arise in vacuum chamber. In USA, there is a company called Cooper's Power System, which produces FR3 oils. These are vegetable-based oils and they are not recommended for mixtures with mineral oil because of probable negative reactions. Another problem one can meet without regeneration is a disposal of oil. Oil disposal should be done by a licensed waste company. Disposal should be the last oil application, as it has its cost and can further be used in the same or other electrical equipment. We have mentioned today that oil regeneration plants can be stationary. Here you can see flow chart typical for stationary regeneration plants. Through the pump, oil comes to a heater, then enters chorus filter, passes through Fuller Earth and leaves the plant. Reactivation is located in Fuller Earth columns box. GlobeCore manufactures mobile plants, which are mostly demanded by the customer, as experience proves. Such plants have a degasser because oil must be degassed before it goes back to a transformer after regeneration. But if you've got a degasser at your site, you may only need the plant exposed above. Could you remember that during this talk we have been touching the advantages of regeneration versus oil change? Now we've got them. No interruption of transformer operation, which could bring a customer to money loss. No environmental spoilage. No exposing of transformer core to atmosphere. No regasketing of top cover. Independence of ambient climatic conditions. Low labor cost, which is a result of one operator to serve the plant. Complete flushing of transformer and its core, what is most important. For example, we have 20 MVA transformer with 20,000 liters of oil inside. Approximate acidity is 0.1. To do the job with regeneration plant, it takes about 5 days. So initial acidity is 0.1 in oil and in windings. Oil comes to the plant, passes through regeneration cycle and goes back to a transformer. Acidity is reduced to 0.3. This difference seems to be negligible, but because of Fuller Earth to have limited absorption, we will treat only a quarter of transformer, 5,000 liters. And 5,000 liters with 0.03 acidity mixed with 15,000 liters, which are still 0.1 acidity. Now, Fuller Earth independently goes to reactivation and degasser of, let's say, 4,000 liters per hour capacity, continues mixing oil in a transformer. In 16 hours, oil in a transformer is not 0.1 acidity anymore. It is 0.07. Thus, it causes instability in a transformer, as oil in windings is still 0.1 acidity. So, what happens? There is automatic equilibrium between oil in windings and outside the windings. Because oil outside the windings throws acidity out of the insulation. Next day, oil passes through Fuller Earth again, but this time starting with 0.07 acidity. It means that now we can do half of a transformer. As soon as Fuller Earth gets saturated, we reactivate it, and meanwhile the degasser is continuing to mix. Oil acidity is reduced to 0.04, but acidity in windings is 0.07. Due to the equilibrium, oil in a transformer sucks acidity out of the insulation, and so on and so forth. Oil change does not allow for such gradual acidity decrease. When doing a change, you can just flush and spray transformer out, but after a couple of time, equilibrium comes and brings acidity to the new oil from the windings again. Here you can see some results of oil tests carried out in 2 years after regeneration. Especial attention we should give to acidity, breakdown voltage, resistivity, dissipation factor, oxidation stability, and interfacial tension. I'm sure now you have revealed all the benefits regeneration gives to your customers and thus brings opportunity of new income to you. So, you will make up the rightest decision, and we will always be pleased to assist all your inquiries the best way anytime. Thank you for attention and good luck.